Hello and welcome to this bonus video about the proof of the derivative of the natural log. In the previous video I just kind of stated that the derivative of the natural logarithm is 1 divided by x, but today I want to try to prove this statement by the definition of the derivative. So if you remember the definition of the derivative, so I'll just say the derivative of a function fx is going to be this certain fraction. It's the derivative of, it's just f of x plus a tiny nudge to x, subtract off just a regular function and divide that by that tiny nudge. And specifically it's what happens when this tiny nudge approaches 0. So let's just fill in ln x for, or log of x for our function f, and that will give us this. Alright, and then just a regular function and divide out by delta x. Okay, so now what we're going to do is we're going to take advantage of the logarithm identity or rule, if you will, that if you have two logarithms subtracted, that's just the same as the two insides divided by one another. So that's a divided by b all inside the logarithm, and we're going to do that with these two. So we'll divide out by x right here, so that's going to be x plus delta x divided by x, still all over delta x. Alright, and now we'll do another logarithm rule. So this is logarithm rule 1. The second one we'll take advantage of is if we have something multiplied by a logarithm, that's the same as raising the inside of the logarithm to that power. So kind of this jumps inside like that. So these two are the same, and we'll do that right here because if you notice we have a factor outside of this logarithm, like so. So we can raise the inside of this natural log to the power 1 over delta x. So we'll do that now. Alright, two brackets, here we go. All to the power of 1 over delta x. Alright, so now we'll do a little bit of a strange step, but it will make sense in a moment. We're going to define a new variable, n, and that's going to be delta x divided by x. And the thing to notice is that because delta x gets really small, that means that n also gets really small. So we'll just keep that in mind. So n is getting really small, delta x getting really small. Just keep those things in mind. Alright, now quickly rewrite this to say that delta x, will just multiply out x by both sides, is n times x, like that. And now we'll fill in this new identity, so we'll be using n in our equation here. So that's going to be, well, let's copy this. So that's going to be x plus, well, delta x, but that's n times x, like this, divide out by x. Alright, and we'll raise that to the power of, well, delta x, but that's just n times x, so n times x, like that. And now we have a power. We'll take advantage of a certain exponent rule. So that's the first exponent rule, like that. If we have something, say a to the raised to the power of b times c, we can rewrite this as saying a to the power of b to the power of c. Right? So if you raise an entire thing to another power, then you can just multiply the powers together, like that. But here we'll go this way because we have n times x here. And what we're going to do is we're going to take three brackets here. We'll take this, we'll do 1 over n, and then we'll take the 1 over x outside, and we'll actually do the reverse of what we did up here. So we're going to actually take the power outside of the log now, and that power is 1 divided by x, and already we can see that this is going to lead us to the right answer. But we just have to see that this equals 1, what we're going to get here. Alright, so that's going to be x plus, like so, and 1 over n. Alright, so it's going to be x, and I'll just divide out by x here. ln, or actually you can just do ln like that. So I'll divide out by x, that's going to be 1 plus n, 1 over n, like this. And now, this is the second thing to notice. This inside bit, I'll actually take this out real quick to make it extra clear. So as n, with n approaching 0, this is actually the same thing as the definition for the number e, right? If you don't know where this comes from, you just watch the exponent derivative part. That's where I showed the derivation for this formula for e. We can just plug e into here, so we'll get the natural logarithm of e. That's our derivative. Now, what's the natural logarithm of e? Now, if you remember, the natural logarithm is actually just defined to be the logarithm base e. So the logarithm base e of e, what's that? Well, if you get the logarithm of base 2 of 2, it's basically saying what do you have to raise 2 to get 2? Well, that's just 1. So this is always going to be 1. So this is 1. Of base e of e, or ln e, that's just 1. So this is going to be 1. And then we'll just be left with 1 divided by x as the derivative for the natural log. And that's where this comes from. So thank you for watching, and I'll see you in the next part. Bye bye.